Okay, so today we're gonna discuss experiment 3 and then kita akan tengok experiment 4. So experiment 3, I tengok you punya lab report yang you guys hantar, and I tak semak lagi because I'm giving you the chance untuk tengok and fix apa yang salah. And most of you ada tengok that most of you still salah dekat a few part where it involve calculation. Okay, one thing is calculation, but other thing yang you have to take your own initiative is your grammar. Okay, remember dalam methods always passive dengan past tense. So tak nak lagi kalau ada is or anything yang present atau other than past tense. Okay, because method ni is not a procedure. Method you dah cerita yang you dah buat eksperimen, so you have to tulis dalam passive and past tense. You dah buat eksperimen, right? Another thing, a common mistake is calculation. Alright, so in you punya eksperimen, okay, you take contoh Burette readings. So we have 4 significant figures, right? Kita guna 4 significant figures. Since kita guna 25.45, any calculation yang involve the reading from the Burette must not be lower than 4 significant figures. So contohnya, you dah kira berkaitan ni semua, and then you kira dia punya molarity, right? Molarity, tengok berapa banyak decimal point yang dia ambil. Dia ambil 3. Why? Because it has 4 significant figures, right? Just a general rule lah. The more the better, because sometimes you dah round off jadi 1.02. Okay, when you do the calculation, cari moles, lepas tu you cari dia punya mass nanti semua, dia dah berbeza. And you should apply magnesium lah untuk this experiment. Okay, another things that yang I tengok a lot of people are still confused with this experiment. Okay, molarity of the standard HCl solution. Kita nak guna formula mana? Mana pergilah tadi? Sini. So, untuk standard solution is kita guna formula untuk standard HCl. Okay, standard HCl yang kalau di react dengan standard NaOH, so sodium hydroxide. Okay, kita bukannya kita guna the formula for reacted metal yet. Okay, sebab dalam the solution dekat bawah Burette kita ada conical flask. That one baru kita ada the metal. Kita baru ada metal yang react, yang kita dissolvekan dalam the HCl. That is where kita cari dia punya nak cari dia punya molarity. And a lot of you still a few of you still salah the volume. Okay, mana you dapat volume, mana you dapat the volume of NaOH. Okay, MV over MV equal dia punya stoichiometric coefficient. So this is the moles of HCl darab dengan the volume the molarity of HCl. Okay, this is bukan mole tau, this is molarity. Molarity is moles over volume dia. So molarity darab dengan dia punya volume over molarity of NaOH darab dengan dia punya volume is equal to dia punya stoichiometric coefficient, which is the number depan sini. Even though tak ada, does it make sense kalau satu dalam HCl sama dengan HCl saja? So that's why dia orang tak tulis. Dia tak tulis lah 1. So kalau 2, 2 lah atas ni. Okay, the volume yang I nampak a few people yang still pening. Okay, NaOH kita dapat from titration lah kan, sebab kita titrate NaOH, right? So buat macam mana kita nak tahu the volume for HCl. HCl datang daripada you punya lab manual. Lab manual ada, so tolong baca. Lab manual dah bagi tahu berapa banyak HCl yang kita perlu guna. Okay, the same thing you buat untuk this and this. I think the calculation most of you got it right and tak ada masalah. Just take a look on the skema jawapan. I give dekat a new channel where it is called Amali Materials. Download it, okay? Download and correct apa yang salah. Okay, tengok where the marks datang. So the reason I give you the schema is not because I want you to tiru the schema. No. The reason why, because nanti untuk practical test, I tak boleh nak ajar you apa yang you should buat, macam mana calculation you should do, right? Untuk practical test, you are given a video or maybe a question, describe the experiment lah, but most likely you will be given a video and you are required to write the lab report. And maybe akan ada extra question yang you kena jawab dekat Google Form ke macam tu. So remember, untuk experiment there's a format that you have to follow. This is untuk lab report, it is a formal paper. So it must have a title, objective. One thing I always point out, mesti ada two. Macam mana you nak tahu objektif ni datang dari mana? You tengok lab manual, tengok dia punya aim. Ayah. So mana satu tadi lah? Dekat sini. So apa yang saya cakap tadi? Saya pun dah tak ingat. Oh, sini. Objektif. Objektif is always ada perkataan to, okay? Dalam bahasa Melayu is untuk, because objektif you punya experiment untuk buat something. So to standardize. Nak tahu nak tulis apa is you dapat daripada aim of the experiment. Aim of experiment ada dalam lab manual. Okay, introduction saya cakap is always make it short. Tapi kalau ada any question, always include a question. Make it short and concise. Tapi janganlah pendek sampai tulis to titrate. No. Ataupun to do back titration. No. Okay. Is based on that. Okay. You make it short and make it in a point form. Okay. Try to summarize. Macam summary you buat BI dulu. Kan? BI ada summary kan. Then method, saya dah bincang tadi pasal passive. And then result. Dalam result, all of you punya table, all of you punya data recording dalam result. Okay. And kalau untuk average bolehlah masuk kan. But usually result kita tinggalkan untuk result sahaja. And then daripada result, we usually akan ada calculation. So calculation involve the data that we got from the result. You do the calculation. This is all the calculation semua. And sometimes calculation also campur dengan discussion. Okay. Kalaulah from the you punya calculation, you have to write a little bit. Okay, macam error ke, ataupun form you punya calculation rasa dapat salah, like maybe you dapat 250 gram per mole, and then you need to do a discussion. Okay, does it make sense that experiment yang you buat dekat lab college matrikulasi, to use a metal ke ataupun any elements yang mass dia 250 gram, the molar mass, those elements are most likely radioactive. Those high mass elements are mostly radioactive. Does it make sense? If it doesn't make sense, and you already double check you punya calculation, is correct, okay, it's okay. Doesn't mean that you akan lose mark. You just have to do discussion, cerita on errors, right? Apa yang errors you buat and how to improve the errors, kan? And then dah habis you punya discussion, okay, you masukkan conclusion. So conclusion datang dari mana? Okay, the conclusion datang dari mana? The conclusion, you should include the any chemical equation yang ada from the experiment, you include. Tak perlu banyak-banyak pun. And then the conclusion always datang daripada aim tadi, which is you punya objective. So objective you is to standardize hydrochloric acid solution and to determine the molar mass of alkaline earth metal by back titration methods. So dia bagi tahu lah di hydrochloric acid solution tu yang you standardize berapa molarity dia yang you dapat, and then berapa molar mass yang alkaline metal yang you cari tu you dapat berapa. So does everyone okay so far with how we write a lab report? Okay, balik nanti try tengok balik you punya lab report and fix it and hantar balik, submit dalam Google Classroom yang sama, hantar balik tempat yang sama tu. Ada any question ke? Question, soalan, pertanyaan? Okay ke? Because nanti lab test, practical test, ada lagi salah yang sikit-sikit ni yang macam format salah tu, maka awak kena tolak. Memang saya dah tak bagi second chance. Ada soalan ke? Semua okey ni? Okey ke? Semua okey?
Yes, sir.
Okay. Okay, kot.
Sir.
Korang ni, saya tanya je tak ada soalan. Yes. So dalam graph, kalau graph usually dalam calculation, sebab result you masukkan apa yang data you catat. Contoh macam experiment 4 you ada catat data kan, volume ke temperature, pressure, catat dalam you punya result. Untuk graph, masukkan ke dalam calculation. Okay, so kalau tak ada soalan ke? Kalau tak ada soalan, saya nak proceed with experiment 4. Kita kan I'll brief again on the how to use the gas simulator, and then kita akan tengok apa yang diminta. Presenting. Okay, so I hope you guys nampak the simulator and the and the lab manual lah. So lab manual untuk home based experiment only datang daripada PDF home based experiment, which you guys boleh dapat dekat Google Classroom. Okay, so untuk this is our chapter 5 punya topic, where you learn about gases law. Okay, this is a similar concept of like macam pressure cooker semua tu kan. So untuk this experiment, the thing yang you guys akan tengok is Boyle's law and Charles law. Where Boyle's law kita akan keep the temperature constant, temperature ni akan constant, tapi untuk Charles law kita akan keep the pressure constant. So kalau untuk Boyle's law, temperature dah constant, we are looking the relationship between the volume and the pressure. Okay, nak tengok betul ke bila you dah buat graph dapat yang sama. And then untuk Charles law is pressure constant So kita nak tengok the relationship between the temperature and the volume. Okay, macam mana dia react to each other. So you guys nampak kan my PowerPoint? Nampak ke?
Nampak.
Oh, very good. Okay, so untuk Boyle's law, so I give you a brief example. So untuk Boyle's law, that a constant temperature, the volume at a fixed mass is inversely proportional to the pressure. So maksudnya volume is inversely proportional to the pressure kalau temperature tu stay the same. Tapi this is relationship, which is the proportional relationship. Untuk equation, daripada relationship kita nak tukar ke equation, we must have a constant where we represent K as proportional constant. Okay, so macam mana diorang dapat this relationship is macam ni lah. Kita buat eksperimen, diorang tengok apa yang berubah. So each of these have multiple graph. Okay, so if kalau diorang tengok pressure against volume, the graph yang diorang plot become like this. Okay, because it is inversely proportional. I believe you already learned about graph in mathematics. Okay, tapi kalau kita buat dengan data where pressure versus dengan 1/V, the graph become a linear because it is a directly proportional. Okay, because kita tengok kalau V kita terus tengok dengan P, it is inversely proportional kan. Tapi kalau V kita tengok dengan the whole of 1/P ataupun 1/V, they become directly proportional and the gradient is K. And kalau it is PV dengan P, dapat straight line which is the constant. So I'm just saying that you punya graph should look like this, wink wink, right? So you should have an idea because you punya graph is dia tanya pressure versus volume. Am I right? Betul tak? Untuk Boyle's law. Dah baca ke lab menu tu? Dah baca ke?
Ada sir.
Ada. Okay kan? So the question tergerak habis. So untuk Boyle's law, apa yang you guys perlu buat is, mana hala tah dia pergi? Sini. So plot the graph of volume versus pressure. So kalau volume versus pressure, you should get like this lah. Because kalau volume versus pressure pun, kalau sini yang volume pun and sini is pressure, the graph will still be the same kan? Betul tak? So this is what your graph should dapat. Okay, then untuk Charles law, kita constantkan pressure dia pula. So untuk Charles law, bila pressure constant, the volume is directly proportional to the temperature. So this Charles law explain kalau you guys siapa yang naik basikal and pump tire, kalau you pump, you keep pumping the tire, kalau you perasan pump the air pump tu akan start rasa panas. Okay, those panas bukan come from the friction, is coming from you keep compressing the gases. Those gases are closer to each other, which is it heats up. Okay, diorang langgar each other. So that's why it is directly proportional. So untuk Charles law, you should dapat there are two type of temperature pula, graph. Okay, you have two type of graphs. Okay, depending on you punya unit of temperature. Kalau unit tu dalam Kelvin, right? Kelvin, which is the unit dalam this simulator, you should dapat graph like this. Okay, Tapi we are usually akan guna degree Celsius kan, which is kita punya normal unit of measurement. This is the graph where kalau you extrapolate the graph, you akan dapat to negative 273.15. This number is the number of 0 Kelvin. 0 Kelvin is equivalent to 273.15. So this number is called absolute temperature. Absolute temperature ni is very hard to achieve. Very hard. Because at absolute temperature, we have zero energy. Okay. So even though sejuk, even though you sejukkan air, okay, you tahu liquid kan, air dia ada molekul you belajar dulu phase kan, and then kalau phase you belajar and then you sejukkan air, the molecules duduk rapat-rapat tersusun. Okay, even though air kita dah beku kan, this molecule still vibrate, dia gerak-gerak, dia goyang. But at absolute temperature, all of the atom tak gerak. So that is absolute temperature. We extrapolate. Okay. So in this experiment, you are tasked, okay, untuk verify from the simulation whether Boyle's law is correct or not. Okay, based on information you dapat from the simulation, betul ke Pakcik Boyles ni cakap ataupun dia kencing dia. Okay. And then Charles, betul ke Pakcik Charles ni cakap. Okay. So that is the backstory of this experiment. Kan? Siapa? Ada orang tanya ke? Oh, lag ke? Saya lag sampai mana tadi? Can you let me know I lag dekat mana? Sini saya dah cerita ke pasal Boyle's law? Beberapa saat lepas. So I hope you guys nampak lah tadi the graph kan. Graph tu you guys nampak kan? This slide ada dalam you guys punya lecture note lah yang I dah give you. Okay. So you just are trying to verify these two law. Wow, so accurate. 10 seconds ago. I wait 10 seconds so it should cancel out. Okay. So Boyle's law dengan Charles law. Okay, we are looking at this too. So let's try to use the simulator. Okay, because this is a bit confusing when nak keep the pressure constant. So nampak korang nampak. So okay, go. So procedure. So ada link dekat situ kan, procedure dia. And so untuk senang choose gas A lah. Senang, memang dah senang, dia dah automatically choose gas A. So the first thing yang dia suruh is, okay, clear the container by tapping the gas valve. Valve tu is dekat sini yang warna merah ni. So you click once, dia akan keluarkan all the gas. Okay, dia macam kentut tu. Okay, dia kentutkan all the gas and then set the constant temperature between 250 or 300 Kelvin. So cara dia is, kalau you tekan, it will keep heating up. The way you nak stop is macam you cool, you stop. You tekan, you stop. Okay, you have to click untuk bagi dia stop ataupun start. So contohlah dia nak 250, so I tak naklah 250, saya nak 270. So tepatnya. Okay, so buat 270 and then press down the gas pump once. Okay, kalau you make sure you tekan A, ataupun kalau B tak apalah, tapi just untuk senang kita guna A lah. So tekan A, make sure A tu is highlighted and then you pump once. Alright, so you pump once. Now we are keeping the temperature constant for Boyle's law, right? So what you are trying to do is, untuk step 4 is a bit confusing. Dia cakap repeat step 4, maksudnya kita kena keep setting constant temperature ke? So tak perlu. So what I need you to do, okay, you need to repeat 4 times kan, to obtain the 5 sets of data. So this is the first set of data, the temperature, the volume, the pressure, the kinetic energy, and the speed lah. So this from the data. So you have volume and pressure. So because untuk charge nanti you akan perlukan okay, here untuk here you perlukan average kinetic energy. Okay, untuk charge you perlukan average tu, nanti you kena catat sekali average kinetic energy, and then this is the speed of the gas particle. Nampak tak? It is meter per second. So untuk charge, tapi untuk voice tak apa lagi, tak perlu. So you perlu catat the volume and the pressure. So this is the very first volume is 665 liter, and then pressure is 1 atmosphere. Okay, the procedure asks you to do 4 times to obtain 5 sets of data. This is your first set of data. The second set, okay, sama macam tadi, you tekan and then you tekan balik to stop. So the second data is 574, the pressure is 116. Do it again sampai 4 times. Okay, and then okay, and then okay. Tu dah berapa? 3 ke 4? Tak apa, bagi 1. Okay, so every time you stop, take note of the volume. So volume berapa, pressure berapa, and make sure the temperature dia tak gerak. Kalau temperature gerak, bermaksud you are doing something wrong. Okay, so that is for Boyle's law. Now kita tengok Pakcik Charles ni. Okay, untuk senang, untuk make sure yang you punya data is correct, you refresh the page. Tunggu dia refresh. So follow balik. Okay, first buang all this gas dulu. Kita buang dia. Okay, biarkan this, kita all the gas terkeluar, and then set the temperature to 250 to 300. Tadi 370, now I nak buat 280 lah. Tak apa, 290 pun okay. I'm happy with 290. Okay, so follow the same thing. Press the gas pump once. So now it is okay. Kita dah masukkan gas kan, and then dia cakap change the temperature of gas and record the respective volume of pressure. Okay, take note make sure the pressure is constant throughout this process. So macam mana kita nak keep the pressure constant is you click this so that you unhighlight it. So it should nampak gelap. Okay, you should nampak gelap. Okay, so you kena change dia punya heat ataupun volume. Okay, doesn't matter, you can change either way lah. Okay, because now what is important, kita keep the pressure constant. So contoh I keep the volume sekejap sekejap. Sepatutnya you punya pressure is constant. Macam mana saya buat tadi tu? Okay. I got it. Sorry, saya pun dah terlupa. Okay, kita buat balik dari awal. Kita cool down sampai 280. You press the gas, right? Tutup. So what are you changing is the temperature lah. Jangan change the volume, nanti pressure dia also bertukar. So you cool down. Okay, repeat step 4 to obtain 5 set of data. So the very first is you dah boleh set of data, and then you can cool down. Okay, catat dia punya temperature and the volume. Okay, or otherwise is you nak heat up. Okay, boleh juga you nak heat up ataupun nak volume. So just make sure you have a 5 set of data, a different 5 set of data, and then plot the graph extrapolate until V equal to 0 to obtain the absolute zero temperature. Okay, untuk this, you are using temperature Kelvin. So, if you are using temperature in Kelvin, you punya graph should dapat dalam this kind of format. Here is like this. So it is directly proportional. Temperature in Kelvin and volume should be dapat when through the kosong. Okay. So I think that's it. Yang pening sikit tu. Just remember untuk charge tu you ubah the temperature, not the volume. Nanti volume dia tergerak. So like this, like this, like this, and the additional exercise you kena buat lah. Itu saja. And then the due date is next week, Monday. Ada any question ke? Yes, kat calculation. Because dekat you punya apa benda ni, you punya results is this lah. The table are given, you just masukkan. Alright, and then this one also kena masukkan. Boleh, tapi kena bayar RM10. No, just kidding, just hantar je. Kalau saya masa tu saya tengok lah. Yes, explanation. Untuk explanation, you boleh letak dekat discussion. That's the point of discussion. You nak discuss apa yang you dapat from calculation. Okay, so like normal, you ada title, and then you ada apa benda tu, you punya aim, which is mana hala saya punya tu, here sini. You ada title, you ada objective yang you dapat dari aim, introduction, method the form procedure ditukar ke past tense, result, all the data yang you catat, which is table, most of the time tables, average you boleh letak sini. Calculation average is quite simple lah kan. Calculation is kalau graph from the calculation, you dapat anything yang you perlu calculate, all dekat calculation. And then kalau lah ditanya pasal apa tu, pasal graph tu obey Charles law ke obey Boyle's law ke, letaklah dekat sini. Okay, untuk temperature dengan gas, kalau lah contoh you guna temperature is 280, please tulis you guna temperature 280. Dekat mana nak tulis? Dekat results. Yes, dekat results you letaklah you guna temperature dia maybe 275. And also dekat result also tulislah juga you guna gas A contohnya. Ataupun you guna gas B. Please jangan campur, sebab for this experiment we like to keep our variables constant lah, the gas. Absolute zero tu yang kita dapat tu mesti Z273. Okay, kan tadi saya cakap kita guna temperature in Kelvin. So the graph should dapat right on 0 Kelvin. So directly proportional. Kalau lah kita guna degree Celsius, okay, dia require degree Celsius ke dalam data tu? Mana. Okay, yes. So you have the temperature of gas. You guna the temperature of gas in Celsius. Mana nak dapat, macam mana nak tukar? Okay. In Kelvin. So kalau you guys tengok you punya tutorials, so we have a set of constant. Mana ni? Alamak, tak ada ke? Okay, so doesn't matter. It is 273.15. You guna 273.15. That's more accurate. Kita accept 273.15. Untuk exam, contoh kalau macam those kind of stuff, Kelvin to Celsius, dia tak ada dalam this part, list of constant. The question will give you the constant. So don't worry. Macam electronegativity value ke apa ke, akan diberi. Period table, most likely tak diberi lah. Tapi you can dapat from here, atomic mass. So, untuk the temperature, so you dapat in Kelvin. So, macam mana nak ke Celsius? Okay. So, apa yang you perlu buat? In Kelvin, nak tukar ke Celsius, is you tolak 273. Yes, very good Vanessa. You tolak 273.15. You akan dapat in Celsius. So, kalau graph tu dia minta is volume versus temperature in Celsius, then kalau you extrapolate, you should dapat 273.15. I know sometimes kita punya graph sengit kan. As long as you dapat 273 is acceptable, and 273.2 ke apa, you should get acceptable lah. And since you guys are using simulator, you punya data should be accurate. 274 okay, as long as 273. Kalau dekat-dekat tu 272, 274 tu saya bolehlah terima. Okay, jangan dapat 280 ke apa, itu dah tak boleh terima lah. Since you guna simulation, you should dapat data yang correct. Apa lagi? Oh, I think that's it for the class. Okay, I'll stop recording.